In today's tutorial, I will discuss 10 multiple choice questions on the topic of kinematics. These are commonly asked physics questions in high school exams. So let me begin with question number 1. Question number 1 is, kinematics is a branch of mechanics that deals with letter A, how an object moves, letter B, why an object moves the way it does, letter C, how and why an object moves, letter D, the application of Newton's three laws describing motion. What do you think is the best answer? Okay, so the best answer is letter A. So the key word here is that you are dealing with how an object moves. We are not talking about why the objects move the way they do. Alright, so we are only concerned with describing the motion of a body, and we never try to explain the reason or give the reason why an object moves. How does an object move requires us to know the distance traveled by the object. So when you say 5 kilometers away, that is a description of distance. How fast does the Earth travel around the Sun is another example of knowing the speed of the Earth as it travels around the Sun. What is the acceleration of a freely falling body? Okay, so that's asking for the rate of change in the velocity of a freely falling body. Such descriptions like slow, fast are examples of words that you have to use in describing how an object moves. Okay, now let's go to question number 2. The quantity that answers the question, how far has the object traveled? Is it letter A, displacement, letter B, distance, C, speed, or D, velocity? What do you think is the best answer? How far has the object traveled? Okay, the correct answer is letter B. So letter B, how far has the object traveled, is what you're going to use when you are asking for such question. How far has the object traveled? We don't need to know what the displacement is because, as you probably have determined, displacement requires specification of the direction, not just the magnitude of the displacement, which usually is the same as distance, and it does not also require you to talk about the speed or even the velocity. Okay, let's proceed to question number 3. Alright, before that, these are the terms that are associated to the term distance once again. Okay, how far is Earth from the nearest black hole? Alright, so when you talk about light years or how close is the school to your house, the use of words like 2 blocks apart, these are examples of descriptions that pertains to distance. All right. Go to number 3. The quantity that answers the question, how fast does the speed of a body change with time? All right. So the keywords, notice that the keywords, how fast does the speed of a body change? Is it letter A, displacement, letter B, speed, letter C, velocity, or is it letter D, acceleration? The correct answer is acceleration. All right. So recall that the meaning of acceleration is that the rate of change in velocity. So when the speed of a body changes, or when the direction of the motion of a body changes, we say that there is a change in velocity. In other words, the body is accelerating. We can also add into that the situation where both the speed as well as the direction of the velocity are changing. Okay, so how fast speed changes over time is another way of describing acceleration. Or if you're talking about how slow the velocity of snails change over time. So that's also all about acceleration. And if you look at the data in the table, where the speed of a moving body expressed in meter per second are given, okay, the time elapsed also expressed in second are also given. So let's analyze. At zero time, the speed of the body is zero, means that body is starting from rest. And 1 second, uh, 1 second after, you will notice that the speed of the body has become 9.8 meters per second. Okay? For the next uh, 1 second, meaning for an elapsed time of 2 seconds, the speed is now 19.6 meters per second. And then in the next second, or time elapsed of 3 seconds, the speed is now 29.4 meters per second. Then, after 1 second again, or after 4 seconds from the beginning, the speed is now 39.2 meters per second. And finally, after another 1 second, or a total of 5 seconds, the speed has now become 49 meters per second. Alright, so if you're going to determine the change in the speed in every second, the change in speed over a given time. Alright, so for example, from 0 second to 1 second, okay, what happens to the speed? Changes from 0 to 9.8 meters per second. So there is a difference in the speed equal to 9.8 meters per second. And that happens in or within 1 second. So in the next second, again, what is the change in the speed? So we just subtract 19.6 meters per second minus 9.8 meters per second. We again get the same value, which is 9.8 meters per second. So we can check in getting the change in speed until we reach the last time interval from 4 seconds to 5 seconds, and we will get the same value of the delta speed, or the delta change in speed. All right? there is a constant change in the speed amounting to 9.8 meters per second in every second. Or we usually express that as 9.8 meters per second squared. And you are right, we are talking about acceleration. So let's move on to question number 4. We have the quantity that answers the question, how fast is the object moving and in what direction? So what is that quantity that we need in order to answer this kind of question? Is it displacement? Is it speed? Is it velocity? Or is it acceleration? So the key word here again is, or phrase is, how fast and in what direction. So those two key phrases are what you're going to use in analyzing this question. Is your answer equal to letter C? All right, that is the correct answer. Okay? Those who answered letter B, we cannot consider letter B because it only answers the question how fast. And you are not in any way particular about where the object is headed or where the object is moving to. Okay, the best answer is velocity, because velocity, as we all probably know, is a description of the speed of a body in a specific direction. Moving on to number 5, a body in uniform motion has constant blank. Is it direction of motion? Is it speed? Is it velocity? Or is it acceleration? So in this question, the key word is the word uniform motion. Okay? So what quantity is constant when we say uniform motion? Are we talking about direction of motion? So when you see a body moving in just one direction, is that considered a uniform motion? Is it only the speed that doesn't change? Okay, considered a uniform motion? Or is it the velocity that has to be constant, meaning the direction as well as the magnitude, the velocity is or are uniform or constant? Or should it be the acceleration that has to be constant? So if your answer is letter C, then you are right. That is the correct answer. There is a similar term or commonly mistaken description of the motion of a body, and that is uniformly accelerated motion. So when you say uniformly accelerated motion, we are no longer talking about having a constant velocity. That is more appropriate for letter D. Uniformly accelerated motion means that the acceleration is the one that's constant. But here, we are simply talking about uniform motion, which means the velocity is constant. Next, question number 6. For question number 6, we have a car traveling westward with a constant acceleration of -2 meters per second squared. So what does this mean? Is it in letter A, increasing its speed by 2 meters per second in every second? Or is it letter B, decreasing its speed by 2 meters per second in every second? Or should it be letter C, the car is traveling with a constant velocity of 2 meters per second? Or is it letter D, the car has a negative velocity that decreases by 2 meters per second in every second? Okay, to help us determine the correct answer, we need to focus on the keywords in the question. So when we say the car is traveling westward, it means that the magnitude, or rather the direction of the velocity of the car is going west, or negative x, or to the left. And then its acceleration, which is constant, has a negative sign equal to negative 2 meters per second squared. And in option letter A, the word used there is increasing its speed. Okay? Increasing in speed meaning the car is speeding up. Alright? How fast is the speed of the car? How fast is it changing? Alright? So the meaning of speeding up by 2 meters per second in every second, we actually are referring to the acceleration. Okay, the acceleration that is increasing, or constant, but the speed is increasing, no? By an amount of 2 meters per second in every second. Whereas in letter B, it's quite the opposite to what is meant by the answer or option in letter A because of the word decreasing. Alright? Decreasing in speed by 2 meters per second in every second. So A and B are somewhat similar. The only difference is the use of the word increasing in letter A, while in letter B, we have decreasing the speed. Now, in letter C, it says the car is traveling with a constant velocity of 2 meters per second. So the word or words constant velocity, meaning if the velocity is constant, then it follows that the object should not be accelerating. All right? That means we can already eliminate option letter C because it contradicts what is stated in the problem. That is, car is having a constant acceleration, whereas option letter C, okay, emphasizes the word constant velocity. These are two contrasting concepts. All right. Now, for option letter D, the keyword again is the car has a negative velocity, okay, which means that, okay, the direction of the velocity of the car is negative. Negative here is the same as westward or to the left. So it agrees with what is stated in the question. But then again, it also says that the car decreases its velocity by 2 meters per second in every second. So the keyword there is decreases. No? What is going on with the velocity that is directed towards westward? It is decreasing. So we are in fact referring to the acceleration that has a value of 2 meters per second in every second. So which among these options do you think is the best answer? Correct answer is actually letter A. Alright? So why is this so? Why is letter A the correct answer? Why not letter D? Alright? So in other words, since we have eliminated option C and that option B is just the opposite of letter A, but I have already given you the answer, it must be letter A. So the only thing that we have to explain is that why is letter A the correct answer and why not letter D? So let's look at the explanation that I have here. So in case A, supposing the car has an initial velocity of 20 meters per second and the direction is west, while the final speed is 30 meters per second, still going west. All right, so these are the conditions specified in the problem. Okay, let's assume that the time elapsed is equal to 5 seconds. Let us calculate for the corresponding acceleration of the car using the formula v final minus v initial divided by delta t, or the time elapsed. So for v2, okay, using our given quantities or assumed values of v2 and v1, v2 is negative 30, negative because it says west, minus, take note, minus quantity negative 20 meters per second. Again, we are emphasizing that the initial velocity is also directed towards west. So divide this by 5, which is, or 5 seconds, which is the time elapsed. And eventually, what we get is negative 2 meters per second squared, which is the acceleration. All right? So you see, this satisfies the required condition in our question. How about, so we say that option letter A supposed to be the correct answer. Okay? How about case D? Case D is the situation mentioned in option D. Okay, so just like in explaining case A, we also assume the following. The initial velocity, okay, is 30 meters per second going west, and the final velocity is 20 meters per second west. All right? And assuming the same time interval of 5 seconds, what do you think is the computed acceleration? All right, so using the same formula, the final velocity is negative 20 meters per second, okay, minus the initial, which is negative 30 meters per second, all over 5 seconds. So we get a value for the acceleration, which is 2 meters per second squared. In other words, the acceleration is positive. Okay, and this doesn't jive with what was required in the question. In the question, okay, we wanted a negative acceleration, but having this, okay, having this assumed values for velocity, okay, the acceleration came out to be positive. That is the reason why case D is not accepted as a possible answer. Number 7. The equations D equals V1 times T plus 1 half 80 squared and B2 squared equals V1 squared plus 2 times the acceleration A and the displacement D. Are valid formulas? Okay? Except when the body is what? Is it letter A, moving in one dimension? Dimension here would mean in one direction. Okay? One direction without changing direction. That's why it's called dimension. One dimension. How about option letter B? Moving in a straight line path. Alright? Not curved, not in a zigzag manner, but in a straight line path. Or option letter C, starting from rest. Okay, where the initial speed is 0. And the last option is moving with a variable acceleration. What do you think is the best answer? If you choose letter D, then you are correct. is there a need for us to elaborate and explain further why option letter D is the best answer? Take note, the question is kinda tricky. Watch out for such word like except. Alright? Except. What the question wants is just one option here that will not satisfy, okay, the condition for these kinematics formulas to be considered valid. Moving in one direction or one dimension is a very common example when you are applying this kinematics formula. Alright? Moving in a straight line path. So that's quite similar to letter A. Moving, starting from rest. Oh, we all have a lot of examples for this situation. So that only leaves us with option letter D, moving with a variable acceleration. When we say variable, we mean changing. Alright? Changing acceleration. Have you realized that both of these formulas in kinematics, okay, require us to assume that the acceleration of the body must be constant. So when the acceleration of a moving body is not the same or is not constant, these equations are no longer valid. Okay? Constant acceleration, if you also recall, is only possible if the net force acting on the body is constant. Okay? Next question. Question number 8. Which of the following motion graphs best represents the motion of an object that accelerates constantly from rest? Okay. Note, small letter d stands for distance, d with an arrow stands for displacement, b with no arrow for speed, v with an arrow represents velocity, and letter t represents the time. So in letter A, or graph letter A, we have here what we call a distance time graph. Okay, so for letter B, this is what we call a velocity time graph. For letter C, it's a displacement time graph. And for letter D, it's a speed time graph. Notice that the variable along the y here has no arrow. So this is speed versus time graph. Alright, let's analyze each one of these graphs. In letter A, notice that the position of the body as it starts to move is at 0 mark or at the origin. And as time passes, notice that the change in the position is such that it increases. Alright? And the graph, the resulting graph, or the graph shown here, is not straight, but rather it's a curve. It's a curved graph, right? If we talk about steepness, you will notice that the steepness of the curve is increasing. Okay? And what does the slope, okay? What does the slope of this graph represents? The answer is, it represents the value of the speed. In other words, for this particular graph, we can say that the speed of the body is increasing, all right, or speeding up. The body is speeding up. Okay. Now, before we go to letter B, may I proceed first to letter C? Okay. In letter C, which is a displacement time graph, the initial position is also 0 at time 0. But as the body continues to move, all right, notice that there is a decrease in the way the displacement changes. All right. So In a displacement time graph, the slope of this curved line represents what we call velocity. Alright? In other words, this graph, displacement versus time graph, represents velocity. And what is happening to the velocity or magnitude of velocity? Since the graph, steepness of the graph is decreasing, it suggests that the magnitude of the velocity is also decreasing. Okay, since velocity has a direction, what can we say about the direction of the velocity? All right, so if you look at the way the displacement or the position changes, it does change in a way that the final position is greater than the initial position. All right, starting from 0. So in other words, the delta D or the change in displacement will be positive. So that means the velocity is also positive. For letter C or letter D, we have a case of speed versus time graph. The V here has no arrow. So this means speed versus time graph. But this time, the initial speed is not 0 here. Okay? It's not 0. At 0 time, okay, the value of the speed is not 0. It's probably what? 5 meters per second or 20 meters per second. Okay, whatever, as long as it's not equal to 0. And look at the graph line. It is not sloping up unlike all the others that we have discussed. It's sloping down. But the steepness of the graph line remains the same all throughout. Okay? In a speed time graph, the slope also represents acceleration. Okay? But we are only after here the magnitude of the acceleration, because we are only talking about the change in speed, okay, over a change in time, with no consideration of its specific direction. So we only consider this motion to be, this graph to be representing the magnitude of the acceleration. And what is it? Is it increasing, decreasing, or constant? So look, it starts from a higher value of speed, and then at a later time, the value of speed is much lower than the initial. So if you're going to get the change in speed over a change in time, you're going to get a negative change in speed over a change in time. In short, we have here a case where the speed is decreasing, all right, which suggests that as far as the acceleration is concerned, we say that it is also negative. Mathematically speaking, the acceleration is negative. But does that mean that the acceleration is directed? Okay, is it directed to the right or to the left? Okay, I'm talking about the acceleration. We say the acceleration is negative, but does the negative acceleration suggest here that the body is also what we call decelerating, or is it accelerating? Okay. What do you think? Because a negative acceleration could mean that the value of the speed is decreasing, okay, over a certain change in time. Okay, a negative acceleration, when not accompanied by a graph, could actually also mean that it is not decelerating. It could also mean speeding up. All right, we will come to that probably in other discussions. But for now, this shows that the speed is decreasing. So obviously, we have here what we call a decelerating body. All right? A decelerating body because the magnitude, or we call it the speed, is decreasing, which corresponds to the word decelerating. Okay? And finally, we go to letter B, or graph B, which shows a velocity time graph. And obviously, in a velocity time graph, the slope represents, okay, acceleration. Okay? The acceleration with a particular direction, since the variable involved is velocity. Velocity, the change in velocity corresponds to a positive acceleration. All right? So look, initially the velocity at time zero, the velocity is zero. And as time passes, okay, the magnitude of the velocity is increasing constantly. Okay, the way the magnitude of velocity changes is in a constant manner. The steepness of the graph doesn't seem to change. Okay, it remains constant all throughout the motion. In other words, this is the graph that represents a body that is constantly accelerated and that the body starts from rest. In short, this is our answer to the question. All right? I hope that is clear. In question number 9, we have a point A that is 10 meters away from point B. There's a particle that's moving from A to B in 2 seconds and from point B back to point A in 3 seconds. Question: what is the average speed of the particle in the entire motion? Is it 5 meters per second? Is it 4.3 meters per second? Is it 4 meters per second? Or is it letter D, 3.3 meters per second? Alright, so we are going to show why the answer for this particular question, the answer is letter C. Alright, why is this so? So we will look at our simple, what do you call this, solution or working in the next slide. We have the particle starting from point A, moving towards point B, which is 10 meters away. All right. Then the same particle will be moving back from point B to point A. By the way, it takes the particle to move from A to point B a time of 2 seconds. But in moving from B to A, it took the particle a time of 3 seconds. So how are we going to determine the average speed for the entire uh, travel or entire motion of the particle? Let's look at our solution. Getting the average speed, which is equal to the total distance traveled, regardless of the direction, divided by the total time, and plugging in the values, we have 10 meters for the first distance, plus 10 meters for the another distance, okay, d2. All of this divided by the total time, which is the sum of 2 seconds and 3 seconds. So simplifying, we get 20 meters divided by 5 seconds, or an average speed of 4 meters per second. That's why our answer earlier was also 4 meters per second in letter C. For our last question, question number 10, we have a body which has a constant negative acceleration and is moving towards the negative x-axis. Which of the following statements is true or correct? Letter A. Its velocity is increasing in magnitude towards west. B. It is decelerating to the left. Letter C. Its velocity is increasing constantly towards east. And letter D. Both its velocity and acceleration are constant. Alright, what do you think is the best answer here? Which of the statements below is true? Alright, that means only one option is correct. All the other statements are incorrect. Okay, what do you think is your answer? First, let us analyze the meaning of each of the options. For letter A, the keyword is increasing magnitude of velocity. Alright, so this means the body is speeding up but moving towards west, meaning the negative x-axis. For letter B, the keyword is decelerating, which simply means that the body is slowing down, okay, which means that the speed is decreasing from a higher value to a lower value, all right? But the direction of such acceleration is negative. In other words, if you're going to calculate for the value of the acceleration and see what's going to be the sign, it's going to be negative. So that is what is meant by option letter B. A negative acceleration corresponding to a decreasing magnitude of velocity. Now for letter C, the velocity is increasing constantly towards east, meaning that the magnitude of the velocity or the body is actually speeding up towards the east direction, meaning the positive x direction. Okay, so you will notice that option letter C already contradicts the condition given in the question, because in the question it says that the body is moving towards the negative x-axis, and so therefore it contradicts what's stated in letter C, towards east. Alright, so how about letter D? So letter D, both the velocity and the acceleration are constant. Okay, these two what do you call this? Two concepts, velocity and acceleration, being constant, actually are contradicting, because when you say the velocity is constant, there is no acceleration. Remember the meaning of acceleration? If there is a change in the magnitude or in the direction, the velocity, or change in both magnitude and direction. So once the velocity is considered constant, we don't we don't say that it is accelerated. All right, so we were able to eliminate already letter C and letter D. How about letter B? All right, so already you have the answer given there, which is letter A. So in our last slide, we will see why the answer, correct answer to question number 10 is letter A, and why letter B is considered incorrect. Or in situation A, the explanation is very simple. Let's assume that the initial velocity is negative 20 meters per second. We have to stick to the description given in the stem of the question, which says that the velocity are the initial as well as the final velocity are both directed to the left. So we put in here the negative sign, negative 20 and negative 30. And supposing the time elapsed is 1 second. Okay, for simplicity. Computing for the acceleration, okay, final velocity minus initial velocity over the time elapsed, or negative 30 meters per second minus negative 20 meters per second divided by 1 second. So, what do we get? We get an acceleration that is negative 10 meters per second squared. And this is, or this jives with our description in letter A, or option letter A. Negative acceleration, but the body is moving westward. Alright? How about in letter B, or situation B? Although we already discussed this situation a while ago, but let's quantify. Alright, let's quantify what we were saying earlier. Supposing the initial velocity is 30 meters per second directed to the left. Alright? And also the final velocity 20 meters per second to the left. So this satisfies what was given in the question. And then for the same time elapsed of 1 second, let's find the acceleration here. It's negative 20 meters per second, that's the v final, minus negative 30 meters per second, which is the initial velocity, divided by 1 second. When you do your algebra, you will get an acceleration that is positive. Alright, positive 10 meters per second squared, because when we subtracted negative 20 minus negative 30, this actually becomes negative 20 plus positive 30. And that gives us the delta B to be positive 10 meters per second. We divide it by 1 second. That's how we got a positive acceleration 10 meters per second squared. Alright? So, what does that mean? It means that in situation A, we have a situation where the body is speeding up in the negative x-axis. Right? So, exactly what the question was trying to assume. Alright? Whereas, in situation B, the situation B describes a body that is slowing down, another term for decelerating, but actually it is moving in the negative x-axis. So our conclusion was that only letter A is correct, but not option letter B or option letter C, neither option letter D. I hope question number 10 was clear, and this ends our discussion. Thank you very much for watching, and I hope you're going to subscribe. Thank you again.